Hello everyone, today inshallah we talking about Lewis structures, and after that we talk about intra and intermolecular forces. Let's go. Valence electron. First of all, we should know what is valence electron. Valence electron can be determined based on the element position on the periodic table. So for example, group number 1 like hydrogen, lithium, sodium and potassium, it ends with 1 electron, so we draw 1 dot. For group number 2 like beryllium, magnesium and calcium, we draw 2, aluminum 3, group number 4 like carbon and silicon 4, nitrogen 5, oxygen 6, halogen 7 and the noble gas 8. Number of bonds element preferred depending on the number of valence electrons. So in general, group number 7, we have 7 electrons or 7 dots, so we need 1 bond often. Chalcogens or oxygen group, we draw 6, so we need often 2 bonds. Nitrogen as well, we need 3. And carbon and silicon group number 4, we always need 4. When compounds are formed, they tend to follow the octet rule. So what is the octet rule? Octet rule, atoms will share electron or electrons until it's surrounding by 8 valence electron. So let's take an example for a nitric acid, and we applied the steps to draw Lewis structure. First of all, find the total number of valence electrons. So we know for a hydrogen we have 1 atom and 1 valence electron. A nitrogen, from chemical formula, we have 1 nitrogen and multiply by 5 the valence electron of nitrogen. For oxygen it's O3, so we multiply 3 with 6 the valence electron of oxygen, so the total number of electrons is 24. After that, we choose the central atom. The central atom of a molecule is usually the least electronegativity or the highest valence. Okay, group number 3, step number 3, we draw a skeletal structure like that. Connect the atoms to the central atom with a straight line represented at a bond between the 2 atoms. The central atom can have up 4 other atoms connected it. So we start to draw a bond between the central atom and terminal atom. After that, place electrons around outside atoms, like here, and place remaining electrons around to the central atom. So here we draw a bar between each terminal atoms and central atom, but we know hydrogen is always be a terminal atom, not a central, and it will be reach octet rule by 2 electrons, so we have just 1 bar. For oxygen, we need 2 bonds, this bond with hydrogen, the another bond with nitrogen and hydrogen. Here, for oxygen, 1, 2, 3, 4, 5, 6, so we need 1 bond. And for another oxygen, we draw 4 and this bar, but we need another double bond to reach the octet rule. We count the number of electrons, so 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23 and 24, the total number of electrons.